It is possible for some objects to be moving within a medium that is moving, and that makes our problem solving a little bit more interesting. So let's say we have a boat that is trying to go straight across the river. Calculate the magnitude and direction of the boat's velocity relative to an observer on the shore. The velocity of the boat is 0.75 meters per second in the y direction relative to the river, and the velocity of the river is 1.2 meters per second to the right. First thing we need to do is decide on a coordinate system. As usual, straight up on our paper can be the y-axis, and perpendicular to that can be our x-axis. What is nice about this problem is the boat's velocity is going right along the y-axis, and the river's velocity is going straight across the x-axis. So this is a simple matter of solving for a resultant vector by adding two vectors that are at right angles to each other. So we're going to use Pythagorean. In this case, we have 0.75 squared plus 1.2 squared. We're going to square root that, and we're going to have 1.42 meters per second as the velocity of our boat. We can use tangent or sine or cosine, again, whichever one you want to. The opposite angle, or the opposite leg, is going to be 1.2 meters per second. The adjacent leg is going to be 0.75 meters per second. So what we're going to find is the velocity of the boat. If somebody were watching on shore, they would measure the velocity of the boat as being 1.42 meters per second at an angle 58 degrees east of north. So now we have a river flowing towards the east. In order to reach a point directly across the river, a boat points towards the shore at an angle of 53 degrees west of north, with a velocity of 6 meters per second due north relative to the shore. What is the velocity of the current? All right, so what do we know here? We know the river is flowing directly to the east with some unknown velocity. The boat is moving due north across the river with a velocity of 6 meters per second. So the heading of the boat is 53 degrees in the direction west of north. All right, so now that we've sketched this out, it's a lot easier to see what we need. Since the boat and the river are moving at right angles, we can pull out our trig functions and find our unknown sides. We know the boat has pointed at an angle of 53 degrees west of north. And we also know the boat is moving north with a velocity of 6 meters per second. So we know the angle and we know one side. We are looking for the opposite side, so the best one to use here is going to be our tangent function. The tangent of the angle will be equal to the velocity of the water over the velocity of the boat in the water. So rearranging this, we're going to take the velocity of the boat in the water times the tangent of the angle. And solving for this, we find a velocity of 8 meters per second to the east. Another thing we might be interested in is the speed of the boat relative to the current. This would actually be the magnitude of the velocity that we must travel at the 53-degree angle in order to get across the river. So we have our vector diagram. So all we really need to do is figure out which function to use. We know the velocity of the boat and the angle, and we just found the velocity of the current. So we could use sine or cosine, it doesn't really matter. The cosine is the adjacent side over the hypotenuse. So rearranging for the velocity of the boat, we will take the velocity of the boat in the water of 6 meters per second and divide that by the cosine of 53 degrees. This gives us the velocity of the boat relative to the current of 10 meters per second.